Hello, welcome to Soil Mechanics Laboratory, whereby we are going to do hydrometer analysis. And the purpose of hydrometer analysis is to be able to determine the various soil particles within a given soil sample. The moment you go to the field and get the soil sample, you'll find that it is not that dry as such. So if you are to go straight away and sieve using this sieve number 200, which is 75 micron, you will find that it will not be able to pass because of the nature of the sieve size itself, the apertures. So you need first of all to oven dry. And usually when we get the soil sample, we first of all take it to the oven to do what we call the oven drying for a period of 24 hours. After oven drying, you leave it to cool for about 30 minutes, then thereafter you sieve. So I'm going to sieve the soil sample. The soil sample is this, which has already been oven dried. As you can see, this is the soil sample. So I want to sieve using the 75 micron sieve. As you can see, usually the aperture sizes of the particular sieve are indicated on the side of those sieves. So I'm going to sieve the soil. And this is how we do the sieving, by just slightly shaking manually. So when I sieve like this for a few seconds, then whatever passes the sieve, which is this one now, this is what has passed and has been retained on what we call the pan. This is the pan. So what is retained on the pan is what has passed through the 75 micron. You are supposed to get 50 grams. So the moment you get the 50 grams, then that is now what you use for hydrometer analysis. So in front here, I've already sieved my soil sample. This is the sample that has passed the 75 micron, and already this is 50 grams. For you to be able to get to weigh, you use the weighing balance here. So after weighing, you get the 50 grams. That is the soil sample that is going now to be used for purposes of hydrometer analysis. Apart from the soil sample, the other things that you are supposed to have is what we call the hydrometer. This is what will now be able to give us the readings. And usually the hydrometer is marked all the way from 0. For our case here, it's marked from 0 all the way to 30. This is 0, 5, 10, 15, 20, 25, and then finally 30. And you can also be able to read if you want to get maybe 1, 2, all the way like that. It has been marked in such a way that you can be able to get all those readings. The other apparatus or what you require is what we call the reagent. A reagent which has been prepared whereby you have to mix sodium carbonate and what we call sodium hexametaphosphate. You take 7 grams of sodium carbonate and add 33 grams of sodium hexametaphosphate, and you dissolve it in 1 liter of water. You prepare a solution of that reagent. So from this reagent, you are required to measure 100 ml of that reagent. So I'm going to measure 100 ml. That is our 100 ml of reagent. So I'm going to pour it into the first measuring cylinder. I'm going to measure another 100 ml of the reagent. I'm going to pour the next one on the second measuring cylinder. On the first measuring cylinder, I'm going to top it up with water to 1,000 ml mark. So I'm going to pour this water. So I've already topped it up with water to 1,000 ml. So after pouring the water into the first measuring cylinder, the next step is that I need to pour the soil sample into the second measuring cylinder. And I just don't pour it, the soil sample the way it is. I have first of all to use the mechanical stirrer to be able to do that. So I'm going to pour the soil sample inside. All the content that has been measured has to go inside. This is the container, and then add water to it. After adding water, then I now take it to the mechanical stirrer machine to be able to stir the soil sample for about 2 minutes. So after removing the soil sample from the mechanical stirrer, the next step is now you have to come and pour it into the second measuring cylinder. And remember, the second measuring cylinder already has 100 ml of the reagent. So I'm going to pour it inside. I'm going to use the wash bottle. This is our wash bottle. During the mixing, you'll find that some of the soil sample gets stuck within. So you need to use the wash bottle to be able to ensure that all the soil sample which is inside is clean. So when you leave, you are immediately after pouring, then the next step that you are supposed to do is to now start getting the reading. So before I do that, I will have to check, because sometimes when you leave it, you find that within a very few seconds, the soil sample has already started settling. So you need to ensure that immediately you pour it, you make sure that you put your hydrometer before the particles start settling. So I'm going to shake to be able to ensure that all my soil particles are in suspension before I start taking the readings. So I'll just insert it like this and start the stopwatch. I'm supposed to take readings at intervals of 30 seconds, 1 minute, 2 minutes, 4 minutes, all the way like that, up to 40 minutes. This 30 seconds, it's at 25.5. That's our first reading after 30 seconds. This is our tabulation sheet whereby we are supposed to have those data. The next reading is supposed to be taken after 1 minute, and then second minute, all the way like that. At the moment, we are the time which has elapsed is 2 minutes. So I'm going to take the next reading after 2 minutes. That is 17.5. 17.5 after 2 minutes. So we are going to wait until it reaches the 4th minute, then we take another reading all the way like that. As you can see, the first reading was 25.5 after 30 seconds. That is half a minute. After 2 minutes, we have a reading of 17.5. You'll find that these readings goes on dropping with time like that. So we are able to get those readings using this hydrometer. You'll find that with time, it's going to sink. When you have a lot of particles in suspension, you find that it displaces the hydrometer upwards, and that's why you are able to read higher values. But with time, because of the particles settling, you find that now the suspension or the solution is lighter, and that's why you find your hydrometer going down or sinking like that. After the 4th minute, we are supposed to remove the hydrometer from this measuring cylinder, and we put it inside this measuring cylinder, the other measuring cylinder. The purpose of having the second measuring cylinder is to be able to have our hydrometer inside. After removing here, we don't place it on the table, neither do we put it back on this box. We are supposed to put it inside this measuring cylinder until we are through with the experiment. So after 4th minute, we have a reading of 13.5. That is the 4th minute, we have 13.5. So I'm supposed to remove this hydrometer from that and put it inside the first measuring cylinder. As you can see, this is what we call the stem. This is the bulb of the hydrometer. When you leave it inside, you find that the particles which are closer to this, the stem, you find that they are, as they fall, they are going to stick on the bulb. So it makes the bulb heavier and it's going to sink. So we want to avoid those particles sticking on the bulb. We remove it after the 4th minute, because you find that between after the 4th minute, the next time that you are supposed to take a reading is 8 minutes. So you have an interval of 4 minutes. You have an interval of 4 minutes. And again, from 8 minutes to 15 minutes, you have an interval of 7 minutes. So it is that time is that long, say that if you allow it to stay for that period, it's going to collect a lot of the soil particles on that bulb, and it's going to make that bulb heavier and sink down. But you find that the initial reading or the time initially was an interval of 30 seconds. From 30 seconds to 1 minute, and then 1 minute to 2 minutes, you find that if you are to remove every now and then, during that period, you find that you have a very short time span, so that you cannot be able to, the moment it reaches that particular time that you are supposed to take a reading, you find that you'll have gone past that. So because of that time limit, we normally get our hydrometer outside after the 4th minute. At the moment, it's 7 minutes and 40 seconds. So when it's approaching, you again take your hydrometer back to where you have your soil sample, and you insert the hydrometer. That time is enough to be able to ensure that by the time it reaches the 8 minute, the hydrometer has stabilized and you are able to take a reading. So our reading after 8 minutes is that is 5, 6, 7, 7.5. 7.5. 7.5. So again, remove the hydrometer and place it. And usually we hold the hydrometer upright. When you remove it from this, you lift it upright like that, put it again in that upright position. You don't tilt it. So the next reading is supposed to be taken after 15 minutes, which is a difference of 7 minutes, all the way like that. So as you can see, we started with a reading of 25.5 after 30 seconds. Right now at 8 minutes, we have a reading of 7.5. So the moment we get a reading of 4.5 here, we stop at that particular time. We don't go beyond that. The purpose is after we are through, or after getting that reading of 4.5, there's a chart that we have to use to be able to get other readings. So that chart goes up to, or starts from 5.0 all the way up to that. This is the chart, as you can see. So our chart here starts from 5 and goes all the way up to 30. So anything less than 5 will not be of any significance to us here, because we cannot be able to plot on our graph. So we are going up to 4.5 because we are supposed to add, or we normally apply what we call the meniscus correction of 0.5. So when you have a value of 4.5 and you add 0.5, gives you 5. So anything less than 4.5, for example, 4.0, 3.0, all the way like that, the moment you add 0.5, it will not give you a value of 5. So you cannot be able to plot that, or you cannot be able to get a corresponding value on the y-axis. You can only get a corresponding value on the y-axis for values up to 5.0. That's why we go up to 4.5. So these are what we call the hydrometer readings. The readings that we got using this hydrometer, and these are what we have recorded here. That is 26.5, 17.5, 13.5, 7.5, all the way at different time intervals. So the next thing that we are supposed to do is what we call the corrected hydrometer readings, whereby we are applying the meniscus correction of 0.5. So on each reading that we have here, we add 0.5 and be able to get these readings. For example, when you add 0.5 to 25.5, we get 26.0. When you add 0.5 to 17.5, we get 18.0, all the way like that. So these are what we call the corrected hydrometer readings. To be able to get the readings on this other column, we need to use this chart here. As you can see at the top here, it's written hydrometer number 48307. So you have to use a corresponding chart. This hydrometer here is marked, has a number, hydrometer number 48307. So I'm using a corresponding chart for that. You cannot use a different chart. You have to use a corresponding chart for you to be able to now fill this other part, this column. And this is how we do it. For example, our first reading is 28.0, 26.0, I mean. So what I will have to do is, on the x-axis, these are the corrected hydrometer readings. So I'll come down here and locate where the 26.0 is. I will move up like this. And if you look at this point here, we have two inclined lines there. So if you are applying the meniscus correction, you use the lower line. So where the 26.0 intersects the lower line, you move horizontally to the y-axis, and you read off the corresponding or the value on the y-axis. That gives you the reading for this other column. So likewise with the rest, you have to first of all get what is the corrected hydrometer readings. You move up like this, where it intersects the lower line. You again move towards the y-axis and get the corresponding value on the y-axis. So this is how we normally use this tool. If you are applying the meniscus correction, you use the lower one. If you are not applying the meniscus correction, you use the upper one. And you get their corresponding values all the way like that.